Nr should greater than Ns, that is what generating mode. So how it is possible, sir, means yes. So initial source of motivate power, some motivating power such as windmill, water mills, turbines, internal combustion engines designed to receive and modify force and motion as applied by some natural source and applied to them driven machinery. That means already the rotor shaft is start to rotate, but if you are doing externally some windmill or water mill, water wheels and turbines, if you are make use of that resource and make the shaft to rotate in high speed, that means mechanical energy. So in that, so it will able to produce electrical energies. That is what generating mode. So here the stator winding is connected to a three-phase supply in which it supplies the electrical energy. But in this case, torque slip both are negative so that the motor receives the mechanical energy and delivers the electrical energy. You are asking that, sir, we are given stator side as electrical energy. You said that rotor, we are making the rotor speed very high due to some external power. Okay. So due to that, how it is producing electrical energy, sir? If you are asking that question, the important point is here torque and slip both are in negative so that the motor receives the mechanical energy and delivers the electrical energy. That is what generating mode. Okay. So here as usual, but still induction motor not much used as a generator. Do you know why? Why it is not used as a generator? Because it requires reactive power for its operation. That means reactive power means we have to give the external supply power, right? Based upon a windmill or something like that. So that make that what I'm saying is that that will make the reactive power should supply from outside, and if it is runs below the synchronous speed by any means, for example, if suppose we are given external supply to make the rotor to speed high of the synchronous speed. Suppose if it is going below the synchronous speed, again it consumes electrical energy into mechanical energy only. So it will not able to produce electrical energy as the output. So many times it may happen. That is why we not much use as the induction motor as a generator. Okay. So this is what generating mode. Next thing is braking mode. In the braking mode, the polarity of the supply voltage. If you want to break that induction motor suddenly, if you want to stop the induction motor suddenly, just simply making the polarity of the supply voltage change, so that the motor start to rotate in a reverse direction. So as a result, you know that it both going to stop. That means it motor should stop. So this method of braking is known as plugging. So this method is used when it's required to stop the motor within a short duration. Okay. So here the kinetic energy stored in the revolving load is dissipated heat as a heat. So as a motor still receive power from the stator side, which is also dissipated from heat. So if you want to stop the motor, if you are making the polarity from changes, so the motor is going to stop, but still the reactive power and kinetic energies and the supply energies is still there in the motor. That wind all is going dissipated as a heat. Okay. So it will produce maximum enormous heat energy. So for this stator is disconnected from the supply, these heat energies will may reduces.